I'm going to draw out the bending diagrams for each stage of the progressive collapse of the Francis Scott Key Bridge. And as a disclaimer, this is not a professional forensic analysis of the collapse, this is just a little exercise that you can follow along with at home. To quickly overview bending, when we have beams like this with load on it, it's going to bend down in the middle like this. As structural engineers, we quantify this in a bending diagram that looks like this. And then another case where this happens is if we have a cantilever or kind of like a diving board where we have something overhanging, a lot of load on it, causing it to bend down like this. We would draw the bending diagram for that to look something like this. So I'm going to make some assumptions and theorize what the bending diagram looks like at each stage of the progressive collapse of the bridge. So for a continuous beam with 3 spans, the bending diagram would look something kind of like this. Now, one more thing to note is the shape of the Francis Scott Key Bridge is actually an arch and not a single beam. And this is important because an arch will distribute a load through compression and not bending. So in comparison with a straight beam, which will have probably a thicker profile, an arch can be a lot thinner and it's still effective at transferring the load. And this will come into play later with the bridge. To support the span, we'll see compression under the main 2 piers here, and then either lesser compression or some tension on the end piers. Now when the ship strikes the pier and we lose the support, the bridge is going to find a new stable equilibrium using these 3 supports, with a bending diagram that probably looks something like this, kind of like a propped cantilever type of situation. Then you're going to see a lot more compression here,